For this video, we'll be looking at IPv6. For a recap of IPv4, IPv4 addresses are 32 bits in length, consist of 4 sections known as octets, each section separated by periods, and comprised of numeric decimal notation ranging from 0 to 255. IPv6 addresses are 128 bits in length, consist of 8 sections known as hextets separated by colons or double colons, and comprised of alphanumeric hexadecimal notation. Each hexset of an IPv6 address ranges from 0 to 9, then A to F. Each hexadecimal character comprises of 4 binary bytes, either 0 or 1, 0 meaning off and 1 meaning on. That represents a value of 1, 2, 4, or 8. To compare IPv4 and IPv6, IPv4 was deployed in 1981, whereas IPv6 was deployed in 1998. IPv4 addresses are 32 bits in length, where IPv6 addresses are 128 bits in length. IPv4 addresses comprise of 4.3 billion addresses, where addresses must be reused en masse. IPv6 addresses comprise of 7.9 by 10 to the power 28 addresses, where every address can be used uniquely. IPv4 comprises of numeric decimal notation, whereas IPv6 comprises of alphanumeric hexadecimal notation. IPv4 comprises of DHCP or manual configuration, whereas IPv6 supports auto-configuration. IPv6 consists of both a network and a host section. Unlike IPv4's use of a subnet mask, IPv6 uses a / and the number of network bits. To summarize an IPv6 address, addresses can be shortened by replacing multiple zeros with double colons. When the address is seen in double colons, it is then replaced with zeros. However, double colons can only be used once, because it would be easier to identify where the zeros would be missing. Another way of shortening IPv6 addresses is to remove leading zeros. Here, I'll be explaining the different types of IPv6 addresses. Global unicast address, which are publicly routable, where the first 3 bits identify this address, usually starts with a 2 or a 3. Unique local, like an IPv4 private address, isn't globally routable, but it uses the first 7 bits and always starts with either FC or FD. Link local, which is a quick automatic IP address not routable over a network, is designed to only communicate with a particular section of a network and always starts with FE. Multicast. These addresses are sent to a particular group of computers which replace the broadcast address of the IPv4. These addresses usually start with FF. Anycast carry the same prefix as the global unicast, as IPv6 allows the use of the same addresses to multiple devices. Now we'll be looking at subnetting IPv6. For a recap, hexadecimal can range from 0 to 9, then A to F, where each hexadecimal comprises of 4 characters. Each character comprises of 4 binary bits, either 0 or 1, that corresponds to a value of either 1, 2, 4, or 8. To count in binary, always start from the rightmost bit and move inwards to the left, counting from 0 to 9 and A to F, moving 1 character over when you reach F until all F's are met. Converting the above IPv6 address will result in the following binary notation. Using the IPv6 address to find the first 4 and last subnets. Looking at the subnet ID of 6600, we see that the address is a /56. With the remaining 8 bits, we calculate 256 subnets, 2 to the power of 8. The address is then changed to a /64 as we use the remaining 8 bits to calculate the usable address. Thank you for watching my video. Please like and subscribe to my channel.